A main difference between neutrinos and other fermions, such as the charged leptons and the quarks, is that neutrinos are the only known fermions that are electrically neutral. Hence, the measurement of their electric charge cannot determine if the particle is a neutrino or an antineutrino. To distinguish a neutrino from an antineutrino, we must introduce the separate global lepton number. There is, however, no a priori reason for this global quantum number to be exactly conserved in nature. As a matter of fact, it is not known if the neutrino and antineutrino are indeed different particles or not. Let us consider the consequences of the Dirac nature of the neutrino field on the physical neutrinos and antineutrinos. Since we are assuming a Dirac field, we have a priori 4 degrees of freedom, corresponding to the left-handed and right-handed chiral states with positive and negative energy solutions. In terms of helicity states, the 4 degrees of freedom correspond to 2 helicity states for each neutrino and antineutrino. Considering the neutrino case, we label nu- for the negative helicity state and nu+ for the positive helicity state. Similarly, the antineutrino can be in the nu bar- or nu bar+ helicity states. We note that for a massive particle, it is always possible to find a Lorentz boost that will reverse the momentum of the particles. However, the boost does not alter the spin direction. The 2 helicity states of a neutrino or of an antineutrino are therefore connected by such a Lorentz transformation. The charge conjugation operator C does not change the spin nor the momentum, and hence not the helicity. This can be expressed as the C transformation changing a particle into its antiparticle while leaving its helicity unchanged. We should recall neutrinos only participate in the weak interactions and with a pure V-A coupling. This means that the nu- and nu bar+ are enhanced while the nu+ and nu bar- are highly suppressed. Hence, the neutrino nu- and antineutrino nu bar+ are connected CP-conjugates of one another. Similarly, the helicity states that are highly suppressed are evidently also CP-conjugates of one another. One can consider other scenarios. Could the neutrino, like the photon, be an eigenstate of the charge conjugation? Majorana neutrinos would possess only 2 independent states. In the case where neutrinos are Majorana particles, the neutrino and the antineutrino CP-coupled states are also directly connected by a Lorentz boost. We have lost degrees of freedom, and the 4 degrees of freedom of the Dirac neutrinos are reduced to 2 degrees of freedom of the Majorana neutrinos. This is equivalent to stating that the known neutrinos in nature exist only in a left-handed chiral state. A global gauge transformation of our spinor implies. Hence, the Dirac mass terms transforms under gauge transformation as. Therefore, they are invariant under our global gauge transformation. On the other hand, the Majorana mass terms lead to a gauge violation. This is interpreted as the violation of the lepton number in our theory. The lepton number rises as the consequence of a U1 global symmetry, so there is no fundamental principle that allows us to state that this conservation should be exact. In the standard model, violation of the lepton number is not allowed, and a lepton number violating Majorana mass term hence clearly represents physics beyond the standard model.